Hello students, welcome to today's online class. Last class already we discussed about some problems of exercise 5.1. Now in this class you have to take yesterday class we discussed 2 points, 2 limits problems. In this class you have to discuss 3 limits problems. That is f of x is equal to 3, 4, 5. If 0 less than or equal to x less than or equal to 1, if 1 less than x less than 3, if 3 less than or equal to x less than or equal to 10. Now we have to check this function is continuous or discontinuous. Okay, continuous or discontinuous. See children, here you have to check the 1, that is 1 you have to take you have to take certain cases 0 less than or equal to x less than or equal to 1, 1 less than x less than 3, 3 less than or equal to x less than or equal to 10. First you have to check, so what is the limit here? 1 is the limit, 3 is the limit. Okay. So in this problem it will come nearly 5 cases. First, case number 1. Case number 1. Case number 1, that is 0 less than or equal to x less than or equal to 1. Okay. Case number 1, 0 less than or equal to x less than or equal to 1. You have to check the function is continuous or discontinuous. Here x less than 1 is there, but here x greater than 1. But here x less than or equal to 10, here x greater than 3. Okay. For 1 LHL function is 3, for 1 RHL function is 4. For 3 LHL function is 4, for 3 RHL function is 5, and we have to check this full function once. Okay, and we have to check full function once, and for this also same, we have to check the full function using this. Now 0 less than or equal to x less than or equal to 1. For this LHL is equal to, so limit x tends to 1 minus f of x, that is limit x tends to 1 minus f of x is equal to x less than 1 means 3. Limit of 3 is 3. Okay. Now come to RHL. RHL equals to limit x tends to 1 plus f of x, that is limit x tends to 1 plus, what is f of x? X less than 1, less than or equal to 1, but here x less than 3, greater than 1. What is greater than 1? 4. Limit of 4 is 4. Therefore, LHL not equal to RHL. Therefore, f is discontinuous. F is discontinuous at x is equal to 1. Okay. Now come to case number 2. Case number 2. Case number 2 means, that is you have to check the 1 less than x less than 3. 1 less than x less than 3. Therefore, so 1 less than x less than 3, between 2 is there, f is continuous. Therefore, limit, so x tends to c, f of x is equal to limit x tends to c. Okay. So that is 1 less than x less than 3, what is the function? 4. Therefore 4, that is 4 only. Therefore f is continuous. F is continuous. Now come to case number 3. Case number 3, you have to check the similarly, that is 0 less than or equal to x less than or equal to 1. So what is limit now? Here we can't take interval limit. We can't take the limit in the form of interval. We can take, so like this case we can take c, that is limit extends to c f of x equals to limit extends to c. What is f of x? 3. So limit of constant is 3. Therefore f is continuous. Just we got the value now. Okay. For this type of interval, just you have to check the limit and we will get the value. Therefore f is continuous. F is continuous at x is equal to 3. Okay. 3 cases is over. So observe the case number 1. Case number 1 is 0 less than or equal to x less than or equal to 1. Okay. That is it at x is equal to 1. Okay. For 1 LHL is 3. For 1 RHL is 4. This is less than 1. This is greater than 1. This is x less than 1, x greater than 1. X less than 1 function is 3. X greater than 1 function is 4. Okay. LHL equals to limit x tends to 1 minus f of x equals to limit x tends to 1 minus 3 equals to 3. RHL, for 1 RHL is 4. Substitute the 4, that is 4. 3 is equal to 4? No, not equal. Therefore LHL not equal to RHL. Therefore f is discontinuous at x is equal to 1. And you have to check that this interval, this full interval, 1 less than x less than 3. Otherwise 1 less than c less than 3. So you have to take c or x, both are same. Okay. Instead of x you have to take c, both are same. 1 less than x less than 3. 1 less than x less than 3 function is what? 4. Limit x tends to c f of x equals to limit x tends to c 4, that is equal to 4. F is continuous at this interval. And I have to check this interval also. 0 less than or equal to x less than or equal to 1. Same similarly. So for this function is 3. Limit x tends to c f of x equals to limit x tends to 3 limit x tends to c 3. Therefore 3 f is continuous at x is equal to 3. Now we will move on case number 4 and case number 5. Case number 4 and case number 5. See children, case number 4. Case number 4 is you have to check at x is equal to 3. In these intervals you have to check first limit and interval. For 1 LHL is there, RHL is there, you have to check it. For 3 LHL is there, RHL is there, you have to check it. For 10 there only LHL is there but RHL is not there. For 0 only LHL is there but RHL, for 0 RHL is there, LHL is not there. Okay. For 1 LHL is there, RHL is there. For 3 LHL is there, RHL is there. Okay. Functions. Okay. LHL function, the RHL functions is there. But 0 and 10 don't have LHL and RHL functions. For these two you have to check it full intervals. Okay. Now case number 4, now at x is equal to 3. At x is equal to 3, what is LHL? X less than 3. X less than 3 is what? 4. Limit x tends to 3 minus f of x equals to limit x tends to 3 minus what is f of x? 4. That is 4 only. Now come to RHL. This is LHL. Now come to RHL. RHL equals limit x tends to 3 plus f of x equals to limit x tends to 3 plus what is RHL? 5. That is limit of 5 is 5. Therefore LHL not equal to RHL. Therefore f is discontinuous. F is discontinuous at x is equal to 3. Already I checked out for 3 LHL and RHL. Now come to this full interval, case number 5, that is 3 less than or equal to x less than or equal to 10. That is, for this interval you have to take the limit c, that is limit x tends to c f of x equals to limit x tends to c. What is f of x? 5. Therefore 5 f is continuous at x is equal to c. These are the 5 cases of 5 cases solutions of this problem. Okay, first you keep in the mind, first you have to check the function is continuous or discontinuous in this full interval. Second case is you have to check the for one value having LHL and RHL, 3 value having LHL and RHL. First one is LHL RHL, you have to check it. For 3 LHL RHL you have to check it, and fourth case is you have to check the function is continuous or discontinuous in this full interval, and finally you have to check the function is continuous or discontinuous in this full interval. We will move on. That is, f of x is equal to 2x if x less than 0, 0 if 0 less than or equal to x less than or equal to 1, 4x if x greater than 1. Observe children, here x less than 0, you have to check it in one case. For 0, it having LHL and RHL. For 1 also having LHL and RHL. First you have to check x less than 0, that is case number 1. Case number 2. Case number 3. See first at c less than 0 or x less than 0, that is limit x tends to c f of x equals to limit x tends to c. What is f of x? 2x. Therefore 2c. 2c is nothing but f of c. Therefore f is continuous at c less than 0. Now come to case number 2. Case number 2 is for 0, see, for 0 having less than 0 is LHL, greater than is, this is x less than but x greater than, x less than 1 but x greater than 0, 0 having LHL and RHL. Therefore, at x is equal to 0 or at c is equal to 0, both are same. LHL equals to limit x tends to 0 minus f of x equals to limit x tends to 0 minus. What is f of x? 2x. Therefore, substitute the limit, you will get what? 0. Now come to RHL. RHL equals to limit x tends to 0 plus f of x equals to limit x tends to 0 plus, what is f of x? 0. That is 0 only. Therefore, LHL is equal to RHL. Okay. Whenever LHL equals RHL, therefore f is continuous at x is equal to 0. Now, case number 3. Case number 3 is you have to check it 1. First one. At x is equal to 1. Now come to LHL. So LHL is 0 only, RHL is 4x. Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus what is f of x? 0. That is equal to 0. Now come to RHL. RHL is equal to limit x tends to 1 plus f of x is equal to limit x tends to 1 plus what is RHL? 4x. Therefore, substitute the limit. 4 into 1 is 4. Therefore, 4. LHL not equal to RHL. Therefore, f is discontinuous. F is discontinuous at x is equal to 1. Okay, and remaining two cases is there. Case number 4. Case number 4 is 0 less than or equal to x less than or equal to 1. That is limit x tends to c f of x is equal to limit x tends to c 0, that is equal to 0. Therefore, f is continuous in this interval. Okay. Now come to case number 5. Case number 5 is x greater than 1 or c greater than 1, both are same. That is limit x tends to c f of x is equal to limit x tends to c, what is f of x? 4x. Therefore, 4c. 4c is nothing but of what? f of c. Therefore, f is continuous, c greater than 1. See children, for x less than 0, f is continuous. For x is equal to 0, f is continuous. For x is equal to 1, f is discontinuous. For this interval, f is continuous. For x greater than 1, f is continuous. Okay. So this is the solution for this problem. Okay. So I will give the homework for you. That is f of x is equal to minus 2, 2x, 2, x less than or equal to minus 1, minus 1 less than x less than or equal to 1, x greater than 1. This is the homework for you. Okay. So you have to send me in the WhatsApp. I am concluding the class. Okay. Thank you, one and all.